All right. Let's say the same cell is going to undergo meiosis. So, as you know, during meiosis, there's two sets of divisions. First set divides diploid into haploid. Second set divides chromatids from each other. So if I were to draw one cell that was a result of meiosis, I would say there's one, that guy, let's say, ends up right there. That guy, the opposite one, ended up in another cell. Okay? This purple one right here, it got divided into two different cells, right? And this weird orange one, it ended up being in two different cells too. Okay? And then, what are we missing? This blue one, let's say that 4 ended up like that. That's it. Is that diploid or haploid? That's haploid. There is one number 1. There's one number 2. There's one number 3. Where's the orange one? And there's one number 4. That's it. It's one set. So 1 is the haploid number, and that's what I ended up having there. The other two cells, same thing, because we're dividing those up, that up, and that up. The other ones end up in here. Okay? These are 4 haploid cells. There's only one of everything. Right? Is that fairly clear? Let's do one more. This one's a little bit different. All of the chromosomes that are the same color are homologous chromosomes. They have very similar information on them. All right? So let's just say over here that this pink one has a big B on it. Is there any other pink ones? I don't see any. Let's say that this gray one right here has a big G on it. Okay? Let's say that causes the plant to be green or whatever. Is there another G? No, there's no other gray one in here, so it doesn't have another version of itself. So, if you're trying to figure out the nuclear condition, and if you're trying to figure out what the haploid set, then you got to get to number them, right? So I'm going to start big to small. That's number 1. Where's the other number 1? I don't see it. I would call that number 2. I'd call that number 3. I'd call that number 4, right? I'd call that number 5. I'm going to call this one number 6 and that one number 7. So, since there aren't any pairs, the nuclear condition is haploid. This thing only has one set of chromosomes in it. Okay? So what is the haploid set number then? If this is haploid, that's the set. There's 1, 2, 3, 4, 5, 6, 7. One haploid set is 7 chromosomes. So let's say that this thing also exists in the diploid state, right? Let's say that 2 of these fuse together. If 2 of those fuse together into one cell, you'd have a diploid cell. A diploid cell, in this case, there'd be 2 of those, 2 of those, 2 of those, 2 of those. There would be 14 chromosomes in that cell. Question is, can I do mitosis? No, you can't do mitosis on a 1N cell. Can you? Yes, you can do mitosis on a 1N cell. This thing can easily divide. These things line up. All of those chromosomes line up. Now, there aren't duplicates of anything, but it doesn't really matter. They can still line up and separate. So I'm going to get one little purple one, right? I'm going to get one of those long pink ones, and I'm going to get one of these little long, or one of these short blue ones. I'm going to get, I don't know if I have all these colors left, I'm going to get one of these weird brown ones, right? What don't I have? I've got this little mid-sized purple one. I've got some gray one, if I can find that gray one. There's a gray one. 1, 2, 3, 4, 5, 6. I'm missing one. Brown? Weird brown? Where's the weird brown one? Here's one. Oh no, that's this guy. Hold on. I got it. 7. 1, 2, 3, 4, 5, 6, 7. That's still a haploid cell. The other one has the other half of all of those. Looks just like it, right? Still haploid. You can do mitosis on a haploid cell because all you're doing is separating the identical chromatids from each other. So, question is, can I do meiosis on this thing? Is it possible to do meiosis on a haploid cell? It is not possible to do meiosis on a haploid cell because meiosis requires that you have pairs of chromosomes, homologous pairs of chromosomes to separate, right? So this is one of two things. This is a haploid organism or this is a gamete, okay? Could be a haploid organism. There's a lot of simple organisms that live their whole lives as haploids. All right? Here's one that's a little more complicated. I'm not going to show you what it does after cell division, but I am going to ask you a couple questions about a cell like this. First of all, what's a nuclear condition? Think about it. And what is the haploid number? Okay, work on it, work on it. Same colors are homologous chromosomes. Okay, I've run out of patience, so I'm going to name that 1, 1, 1, and 1. Good Lord, there's 4 number 1s. I'm going to call these weird ones 2, 2, 2, and 2. There's 4 of those guys, right? You see what I'm getting at here. These kind of reddish ones are 3, 3. What is that? Oh, it's falling apart. 3 and 3, right? So you're starting to get my drift here, I think, because it looks like there's 4 of everything. If there's 4 of everything, that must be a tetraploid 4N cell. Okay, tetraploid means there's 4 whole sets. Next question is, what is one haploid set? Well, I'd have to continue numbering them to figure out how many different ones there are. There's a 1, there's a 2, there's a 3. We'll call this 4. There's a 4, there's a 4s. That's a 4, that's a 4. And that's a 5. 5, 5, and 5. So one whole set, which means all the chromosomes that are absolutely different from each other, are 5. There's 5 in one set. It just so happens that there are 4 sets. So don't you think that 20 must be the what number? 20 is the tetraploid number, right? I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, let me do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 20. There's 20 chromosomes in there because this is a tetraploid cell with a set of 5. All right? Can this do mitosis? Sure. It would be messy, but every one of those chromosomes would line up in a 20 chromosome line. You guys do it all the time. You has 46. Can this one do meiosis? Absolutely. Most likely what it would do, though, is that the 1, the 1, the 1, and the 1 would line up like that, and you would separate pairs that way. There's also the potential that 1 and 1 would get together and the other 1 and 1 would get like that, and you'd separate, and you'd still have 2 1s over here and 2 1s over there. You'd end up with diploid sex cells, basically. Okay? Does that make sense? I hope so. One last practice one. I'm going to let you figure this out on your own, which means I'm going to give you an extra 2 seconds to think about it. So this, first of all, what is the nuclear condition? Second of all, what is the 1N number? Right? Or in other words, the haploid set. Okay. Take your time. Okay. I'm just going to test you. Nuclear condition. I see 2 purple ones. I'm going to give them homologous numbers. I see 2 blue ones. I'm going to give them homologous numbers. I see 2 pink ones. I'm going to give them homologous numbers. I'm going to call those 3s. I'm going to call these guys 4s. Okay? Oh, I think I screwed up. And I'm going to call these 5s. Okay? So if I have 5 chromosomes that are entirely different, the haploid number is 5. 5 chromosomes that are completely different, right? I would also say that since there's pairs, there must be 2 whole sets of chromosomes in there, which makes the nuclear condition diploid. Diploid and 2N mean the same thing. So far, so good. I have a diploid cell with 5 chromosomes in one set. As a result of that, I have 5 chromosomes twice, so altogether I have a diploid number of 10 chromosomes. Count them yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 chromosomes is the diploid number here. Okay? If I were to do mitosis, very quickly, I would have a cell and another cell with 10 chromosomes in there. 1 purple one, 2 purple ones, 1 little red one, 1 little red one, 1 little gray one, 1 little gray one, right? Every one of those is going to split in 2. I still have 10. It's still diploid. Same thing here. I still have 10. It's still diploid. On the other hand, if this same cell does meiosis, I'm going to end up with 4 cells with only half of 1 purple one, half of 1 blue one, half of 1 pink one, half of 1 gray one, half of 1 red one. 1, 2, 3, 4, 5. I'm going to be back to the haploid number, which is really the point of meiosis in the first place. Okay? Don't put X's, because that means they didn't finish. This thing didn't finish. Those other X's, the other half of that, the other chromatid, it's over here in another cell. All right? So I hope that helped. Keep practicing. Thank you very much.